Bismillahirrahmanirrahim. Welcome to Easy Learn. We are discussing here some. Previously, we are discussing the network analysis basic concepts. First, we discussed the charge, very basic thing about the networks. Every starting of everything, every base of the circuits, the currents, the voltage are based on the charges. Then we discussed the basic two schemes that we are working and our conceptual schemes are based on. Then we discussed energy and the relationship of the power and some parameters and derivations like in the previous episode. And now in today's episode, the topic is a little bit interesting. It is just I'm just in this episode giving you about the relationship of field and circuit concepts, and just telling you that which methodology we are going to adopt for solving out our capacitance parameters and solving the numericals of different conceptual schemes that we are going to use, different strategies. So let's start and discuss what is the basic schemes. Before going to proceed, in the previous lectures we discussed basic things, and they are in it complete. We are following in the complete pattern wise, going with the step wise from lower toward higher. So if you did not discuss the previous or learn or memorize the previous concepts, I always ask you to have a pencil and a notebook and note all the important parameters so that you not go back again and again in watching the videos. Better try to write these steps on your notebooks. In the development of the circuit conceptual scheme, this is the circuit conceptual scheme. This is whenever we have a like this, for example, here it is a source, but I'm drawing here like AC source, but we can have AC DC source or anything. This is also a circuit. Like if we have a bulb connected here and only bulb is using as a resistance, so this is a simple circuit. There are different types of circuit. Circuit is anything which is providing the path, the connection to flow the electrons. They're completing their path like the wires. When we connect the connections, it becomes a circuit. When there are multiple circuits are going to interpret, and there is a complex circuits, and this becomes overall in networks. And this is our final. Maybe we need, if we are going with this speed, maybe we need further so many episodes to cover this lecture, to cover this content. Anyhow, so whenever we are going to solve and developing the circuit conceptual schemes, we will follow these same steps for each of the three parameters. So there are, before going to further proceed, let's first discuss an important issue here, that circuits are actually of the two types. Main categories, there are two. One is the circuit that are using this symbol, that means capacitive circuits, and others that are using these, like that, inductors. So capacitive circuits and inductive circuits. Of course, capacitor is responsible for these type of the effects are coming from the capacitors. And while inductor is responsible in the circuits for the inductive effects, the physical phenomena. First we discuss the strategy and look at the physical phenomena of the circuits. Then we take a look at the field interpretation and then circuit interpretation. There are the three different techniques that we are going with the stepwise. The third one is really important technique. We are focusing on, main focus is on this one, but of course we need to, first two techniques are also important. We will cover up all the techniques, three techniques, in each episode one by one. So in the coming episode, the lecture is on the physical phenomena. But remember that I want to discuss that there are the two types of circuits, capacitive and inductive. So these three techniques are same, but formulas varies. They are sometimes totally opposite to one scheme to the other, because of the inductive and capacitive relationships are different, and different strategies required. So we are not saying that strategies change. We basically, the method is same, but the technique and the route or the course is sometimes changed. So we are going to first discuss the in the next episode the physical phenomena of capacitive circuits, means the capacitive parameters, then field interpretation of capacitive circuits, then circuit interpretation of the capacitive circuits. Then we again going to discuss the same thing with the physical interpretation of inductive circuits, then field interpretation of the inductive circuit, and circuit interpretation of the inductive circuits. Means there are the total 6 episodes that are coming up to cover up the lectures. This is the information that I want to share with you. The coming routine 6 plus this one episode 5 and the coming 6 episodes 5 plus 6 11 episodes. It means that this topic is gonna end in the 6 episodes, more 6 episode, and on the 11th episode, because we are going to discuss in details. That is the basic reason. This slide we already discussed. Okay, let's first discuss the field. Field is the surrounding, the environment of the charge. There are 2 types of the field. It can be either electric field, mechanical field. Let's discuss the electric fields right now. We are not in the mode of power generations. First we're discussing the electric field, sometimes called abbreviated as E field. Simple E is used for electric, and it is a vector quantity because it has a particular direction. Like this is suppose a charge, point charge, and it has a field. Suppose I'm just drawing arbitrarily. There are the direction always with the arrowhead. Suppose we have arrowhead and different directions. And if we have this type of diagram where arrows are used, it means that this has a specific direction, and this is due to this electric field intensity. Its intensity is more here around this point charge. Intensity is going to be decreased as we are going to live away from the charge. It is a vector field surrounding an electric charge that exerts force on other charges. If there is another charge, suppose negative, it has its own field too. Then if there is a boundary, means the limitation of everything, like suppose the limitation of negative charge here is this, what I draw the circle here, and the positive has this. This is the range of the charges where we can, if we go enter into this circle, if we have experienced the force due to these charges. If we are going closer, so that the circles, the boundaries gonna overlap, their force field lines of the one charge can interpret or overlap or just meet up with the next one. Then what happens? There must be a force present between when this scenario happen. Either it is a force of attraction or this will be a force of repulsion. This thing is told by Coulomb, and so that we are always using the Coulomb force, and we are saying this is a Coulomb force. Mathematically, if we are saying the electric field is a vector quantity, because as you know, I draw the arrows here, and that are associated with the each point in the space, and the space usually matters. In the next episode I am going to discuss all the parameters in details when we discuss there that a medium also matters. This affects, if we change the medium, this is air, this is vacuum, this will affect the permeability. Okay, now field is discussed. Now come toward the circuit concepts. As I told you, an electric circuit is basically path, nothing else. A path in which the electrons are flowing from one point to the other, and this is a complete and a closed loop always, because the circuit is complete only when the source and the return point is always clear. If there is a no return point, is considered as an open circuit because electrons can't complete the path of the flow. So it is a closed path. Remember, always this will become a circuit in which electrons flow from a voltage or a current source flow. The point where those electrons enter an electric circuit is called the source. Like say we have here, this is a source as a battery here, positive or negative. If we ground this terminal, like we are saying ground, and here we have a capacitor here, and suppose we have a resistance 2, and this is grounded terminal, this is grounded. So this is the source point. This is where the circuit is going to follow. The direction depends. There are two types of direction we already discussed. It doesn't matter here. The point where the electrons leave an electric circuit is called the return or the earth ground. Okay, so electrons are leaving from here. This is called the earth or the ground point. This can either be a return point if we join. Basically, this is a common point. If we join all these points, we can say simple the return point to the, again going towards the battery. This is the return point with the different energy level. The energy level when they are entering into this circuit as a source, from the source there is high due to the voltage we already discussed in the previous section. This is in the picture a practical circuit on the breadboard. Usually we do this after we implement our basic circuit in the software called different MATLAB, Proteus or Multisim, but then we try to draw the raw material with the help of the what you can say, like if before going to soldering and a professional circuit, we are testing is performed on the breadboard, where we can easily add or remove the components and connections very easily. We will discuss this in the practical section, right? Not right now. Okay, further, now we are going to discuss the methodology that we are going to adopt for finding the basically relationship between the field and the circuit concepts. Either this is the capacitive circuits or inductive. This is the relationship what we are interested in. Physical phenomena, this is the first step, that is the physical phenomena. We will discuss a quantitative manner. Here the important thing is quantitative manner. We are going to follow the track with the help of firstly just taking a look at the circuits. So how many resistance are there, what are the effect and the force, if there are more than one charges are there, the forces of attraction or repulsion by adding or subtracting them, vector quantities, because we can add them graphically. We're not right now discussing. In the next lecture we will go through it. We will discuss in a quantitative manner an electrical phenomena which is observed by the experiment. This is an electrical phenomena which is observed by experiment. We will do this in terms of charge and energy. So this is important thing. In the first step we are interested in the charges and energy, and basically the manner is quantitative, but the base things charge and energy. In the next step we are going to continue with the field interpretation. We will discuss the interpretation of the and the relationship basically of the with the field quantity. In terms of the field, discussion is changed in terms of the field, electric field, with the formulas we are going to I'm sorry, we are going to discuss the relationship, because in the first step we find and calculate the force due to the charges. This is the physical interpretation. Then we are going to change and divert our discussion into from calculating force to electric field, which is calculated with the help of formulas discussed in the next episode. And then we final step is the circuit interpretation, which demands more intention because it is complex portion. Circuit interpretation relate the voltage and current in place of field relationship. Okay, field relationship, it is important. Field relationship, you can say we discussed the circuit concepts, we are going to relate the voltage and current. These are the two basic things that are belong to the circuits. Finally, our relationship should be in terms of the voltage and current, so we can relate whatever the quantity we are interested in. So this is the final step that we want. The circuit interpretation is a larger demand more complexity, so we can divide this. If I would think so, we have to divide this lecture. So in the coming lectures we are going to do all these things, and then numericals, solving techniques. After these, both numericals will be solved, capacitive and inductive. So this is the end of I think episode. If we have another slide, let's check. No, this is the end of episode 5. So further discussion will be continued from the episode 6. So take care. Allah Hafiz.